Behind every great melody lies a world of physics waiting to be explored. From the rolling hills of sound waves to the harmonious vibrations that resonate within us, the science of music is a captivating journey that unveils the hidden principles behind the tunes we love. Have you ever wondered how musical notes are produced or what makes a violin sound like a violin? Join us as we unravel the mysteries of sound and discover the fascinating physics that orchestrates the melodies we enjoy every day. Let's start with the basics. What actually produces musical notes? The answer lies in the realm of vibrations. When a musician plucks a guitar string, violin bow, or presses piano keys, they initiate a vibration. This vibration is a disturbance that travels back and forth along the string or air column of an instrument like a wave crashing on the shore. These waves of vibration are known as sound waves, and their characteristics such as frequency, amplitude, and wavelength determine the properties of the musical note. Think of a guitar string. By changing the tension, the number of waves that fit into a given length of the string changes. This change in wave behavior alters the sound produced. Now consider the air column in instruments like flutes and clarinets. As musicians change the length of the air column by covering holes or pressing keys, the resulting sound waves change, producing different notes. But how do these sound waves translate into the musical notes we hear? It all comes down to frequency. The number of waves at a second is known as the frequency, and it determines the pitch of a note. Higher frequency means more waves and thus a higher pitch. This is why a guitar string vibrating at 440 cycles per second produces a different note than one vibrating at 264 cycles per second. Our ears perceive these varying frequencies as different musical notes. Here's where things get even more intriguing. Most musical instruments can produce not just one note, but a range of notes simultaneously. Have you ever noticed that when you play a piano, middle C is not the only note you hear? There are overtones or additional notes that blend with the main note to create a rich, complex sound. These overtones are produced by the harmonics of the vibrating string or air column. Harmonics are whole number multiples of the fundamental frequency. For example, if the fundamental frequency of a note is 100 Hz, its harmonics would be 200 Hz, 300 Hz, and so on. Each harmonic has its own amplitude, and the combination of these harmonics with their corresponding amplitudes creates the unique timbre or tone color of an instrument. You can experience this for yourself by singing a note and placing your hand on a table. The table will vibrate because your voice is producing sound waves that travel through the air and cause the molecules in the table to vibrate. If you have an opportunity, try playing a note on a piano and placing your palm over the sound hole of a guitar while it is playing. You'll feel the complex array of harmonics in the sound produced by the instrument. Now let us explore how the interaction between sound waves and our auditory system creates the perception of music. When sound waves enter our ear, they cause the eardrum and tiny bones in the middle ear to vibrate. These vibrations are then converted into electrical signals by the hair cells in the inner ear. These signals are sent to the brain, which interprets them as musical notes. The brain's ability to process these incoming signals allows us to perceive the harmony and melody of music. But it's not just about individual notes. Our brains also process the relationships between different notes, allowing us to appreciate the beauty of musical compositions. As we continue to explore the science of music, we'll delve deeper into the physics of musical scales, harmony, and rhythm. So stay tuned and get ready to discover the hidden harmonies that shape the melodies we love. From the strings of a violin to the keys of a piano, each instrument has a unique way of producing sound. But behind the beautiful melodies they create lies a world of physics waiting to be explored. Understanding the science of music not only enhances our appreciation for the art form, but also reveals the fascinating principles that govern the melodies we love. So the next time you listen to your favorite song, take a moment to appreciate the hidden world of physics that makes it possible. And who knows, you might just discover a new appreciation for the science of music. Thanks for joining us on this musical journey through the world of physics. If you enjoyed this exploration of the science of music, don't forget to subscribe for more exciting discoveries. Hit the like button if you want to see more videos like this. And as always, thanks for watching.